Hello dear students, how are you? I hope you're well. So let's start your class of the maths from my side for you. Today I'm going to select that is a chapter of here. What do you mean from the natural numbers and what do you mean from the whole numbers? Actually these are all topics, they are very simple. Do you want to pause this video? Do you want to left this class? Don't worry, if you left this class you will forget all things. They are very important for your knowledge. So dear students, listen carefully what I'm going to present for you. The first of all, you have to try to the story in your mind. What do you mean from the natural? Actually, this is a very simple topics. But why I'm teaching to you? Actually, the students they are confused something about that. For the clarification, for the polish of their knowledge, I want to going to explain that topic. Actually, what do you mean from the natural numbers? So, sorry, it is a very common. Of course, it is a very common. Natural numbers means over all counting numbers. We can say 1, yes, childish question, 2, 3, 4, 5, 6, 7, infinitive. Okay, till infinitive from 1 to infinity numbers, they are called natural numbers. So dear students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are all they? They are called natural numbers. Okay. Second things after, what do you mean from whole numbers? Actually, if I will circle it, so this is a Mr. Bhuju, suppose that, and he is called natural number. This is called natural number. Okay, natural means 1, 2, 3, 4, and 5. Blah blah blah. Okay, dot. Over all these natural numbers, they are countable for you. So primary numbers and composite numbers. Also with them, this is called a natural number. Second things about that. What do you mean from the whole numbers? Okay, whole numbers means what? The whole numbers means we can say here 0 plus 0. 0 plus 0. 0 means this is 1. The 0 plus this number is called whole number. Actually, I want going to tell to you one more step through. Okay. Let's take the enjoyment and we have to also study with it. So we can say whole numbers means, okay, I will tell you, whole numbers means we can say here 0 plus natural number. 0 plus natural number, it is called whole number. Natural number means what? Over all the counting numbers. Over all the counting numbers. Counting numbers. What do you mean from the counting numbers? So 1, 2, 3, 4, 5, million. Okay, so these are all called natural numbers. With it 0, it is called whole numbers. Okay, suppose that I'm going to ask a question. There is a mobile phone, that is keypad mobile phone. Suppose that if you multiply over all numbers from 1 to 10 in the keypad mobile phone, what will be product? Tick 1, 2, 3, 4. Yes, that's wrong answer, correct? You can analyze yourself. But my answer is there 0 because at the place of the 10th there is 0. So when you multiply over all numbers in keypad mobile phone, so we can see here this is called product 0. Second things about that, what do you mean from integers? So what do you mean from the integers? Yes, integers means I can say to you over all positive numbers, over all negative numbers. They are called integers. I can understand. Let's tell me once again. So integers means if I will tell to you, suppose that this is a number line. Here is 0. So here is suppose that minus 5, minus 4, minus 3. Here is plus 1, plus 2, plus 3 over all these numbers. So I can say to you that I can say to you means all positive numbers, yes, all positive numbers plus with it negative numbers. Yes, that's great. Negative numbers negative numbers, what are they called? They are called integers. They are called integers. You understand about that? Are you understand? For instance, for example, if I say to you -1 is a number, of course it is a number. Actually, it is a natural number. No, sir, this is a integer because it has a minus sign. Okay, so let's tell me +1. Actually, yes, this is a natural number. This is a whole number because all numbers they are called positive numbers. So +1 is there. What? The +1 is called also the integer, also natural number, also it is called a whole number. Then after, in the comparison of -36, -48, +3, what are they? They are also called integers. They are also called the integers. -36 integer, -48 integer, 3 integer. So what about 0? Let's tell me what about 0? 0 means we can say 0 is also integer, of course. Of course, 0 is yes integer. 0 is integer. Of course, it is right. So then 0 is a positive integer or negative. So we cannot be determined with a sign. We can say here 0 is not positive integer and here also we can say it is a negative. Okay, so we can say here 0 is neither positive. Okay, 0 is once again. Okay, 0 is neither positive or nor we can say negative. Okay, so we under this category we can put it. Okay, this is not positive and this is called non-negative. Okay, so we can say it is neither positive, it is called neither negative about 0. Second is about which is comes after it. The properties. Okay, properties it will become. Okay, properties it will become addition, then subtraction and multiplication. Okay, so properties I am going to discuss with you. What are they? They are related of the addition, they are related of the subtraction, they are related of the multiplication. These are all the 5 properties of the addition. Closure property, commutative law of addition, associative law of addition, existence of additive identity, and existence of additive inverse. So these are all the 5 identities of the addition of integers. Basically, these are all that depend on based on integers actually. Integers. Okay? Integers. So in this property, closure, commutative, associative, existence and existence. In these 5 properties, I will tell to you how can integers they will be add, and properties of the subtraction I will tell to you how can they subtract. In the properties of the multiplication I will tell you how can they multiply. Okay, very simple but they are very important in the calculation of properties of the addition. Okay, what do you mean from the closure property? What do you mean from the associative law of addition? Existence of additive identity and existence of additive inverse. Let's explain about each one. What do you mean from the closure property? Closure property means when you will add 2 integers, when you will sum the 2 integers, digit will come. Yeah, the addition will come. It is also an integer. Okay, the sum of the 2 integers are always an integer. Okay, let's look at here. The sum of sum of 2 integers. Sum of 2 integers always always integers. Okay, so sum of the two integers always integer. Suppose that two integers are here, a plus b, and you did sum of them. Two integers a and b, and sum of them is equal to always c. So c is also called a integer. This is also called a integer. There are two integers a and b. Sum of them is equal to always an a integer. I will show to you some examples of them. Okay, I want to erase this one. I will give to you some example for them. What are examples? Okay. Okay. So first of all, discuss closure property. I told to you that sum of two integers always integer. Just look at here. Suppose that a and b both are integer. If you will do sum of them, a plus b is equal to c. C is also called integer. This is also called a integer. For instance, it's like a for -2, b for suppose that -3. Let's find the sum of them. -2 plus -3 is equal to what? So we can say -2 plus -3 is equal to -5. So dear student, let's tell me. -5 is there? Yes, very good. -5 is also called an integer. That's good answer of this question. Okay. If you want, I will give to you the next example. Suppose that a is equal to whatever, we can know that about. Suppose that a is equal to -30. Suppose that b is equal to 105. Then find out the closure property. So closure for a plus b is equal to c. This is the formula for the closure property. Second example, let's replace of them. A equal to -13, b is equal to 105. Then after plus minus will be minus 105 minus 13. You can say here 10. We can say 99, 95. 95 minus 3, we can say 92. 92 is there. Okay. Okay. So we can say this is also. So 92 is also integer. 105 is also integer. Minus 13 is also integer. It's just like I know here what do you mean from them. So they are called also integer. Very simple. It's like play a game. Mathematics, we are just chill that about. It is a very difficult. We are thinking about it. It's like a game. We have to play with them. So these are all my balls and bats, and this is also, let's boom this here. Okay. So we have to just play with it like a game. Okay. Second is after closure after. What will come? Yes, commutative law of addition. Second will come commutative law of addition. Second is there. Commutative. Yes, commutative. Yes, commutative law of addition. Law of, we can say, addition. Commutative law of addition. Suppose it, if m and n, suppose m and n both are integers. Both are integers. Hi, Mr. Tarun. Hi, Mr. Varun. Okay, A suppose that m, A suppose that n. Okay, suppose that m, they are suppose that n. At this condition after, if here is m and n, both are Suppose they're integers, so they can plus or they can minus. Okay, so if I will give to the examples of them, so there is a formula should be the create at here. We can say m plus n according to left hand side is equal to n plus m. I also right hand side. So what is the conclusion of this here? If the both integers are here in the commutative law of addition, m plus n, n plus n, in the both conditions, left hand side, right hand side always should be equal in the condition. So how is it possible? The left hand side is equal to right hand side, because there is a m plus n, here is n plus n. So I will give you the examples for it. Yes, example. Suppose that m is equal to minus 2. n is equal to minus, suppose that minus, you can say minus 12 something. M is equal to minus 2, n is equal to minus 2. So let's prove it. The left hand side is equal to right hand side. Okay. I want to say something. Yes. Okay. That's great. Okay. First of all, let's take left hand side. We have to replace to them. M plus n. Minus 2 plus minus 12. We are adding to them now. So we can say left hand side according. Left hand side according. We can say here minus 2. Yes, as usual. Plus minus minus 12 here. So we can say minus 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 will be minus 14. This is your left hand side. So what is left hand side? Minus 14. Let's take right hand side. So minus 12 and plus minus 2. At this condition after minus 12 plus minus 2 is equal to minus 14. Wow! It is proof that the left hand side is equal to right hand side. So m plus n is equal to n plus m. In both conditions, it should be equal. Clear or not? Yes, of course. Okay, so we can see here it's very simple. If you want, I will give to you one more example. Read it off it. Okay, let's see. Are you confirmed about that? Everything is fine there. Very good. Okay, now let's come on the next one. Okay, just look at this. One more example. Example number 2. Suppose that a is equal to a is integer and b is also integer. So at this condition after, we can say a plus b is equal to b plus a. Let's prove it, sir. The first one from this left hand side. A is equal to, suppose that minus 101 and b is equal to 1000. Okay, so you have to prove here. So let's prove it. A plus b means we can say a plus b means we can say a means minus 101 plus we can say 1000. Then after we have to subtract. We can say the is 100 minus we here 900. We can say 900. 900 means 1 minus. We can say 899. 899. Okay. Yes. Okay. That's right. Okay. This is called left hand side. Right hand side after, we can say right hand side. Right hand side after b plus a. B means what? 1000. 1000 plus minus 10. Okay, now 1000 plus minus 101. At last we have to subtract here. 10 minus 1 we can say 9. We can say 9 here. And here is 9. 9 minus 1 we can say 8. Wow, it is a proof that the left hand side is equal to right hand side. In any condition we have to apply a plus b, b plus a. In the both condition, sides will be equal. Okay. Second thing is optional, which will come here. After this commutative law of addition, after that is next one, which are very important. Associative law of addition. Third number. Third number is here. Associative. Associative. Yes. We can say law of addition. Law of addition. Associative law of addition. Okay, associative law of addition. Then after we can say associative law of addition. After we can say here. Suppose that there are three integers. If there are three integers. Suppose that there are three integers. Like A, B, and C. A, B, and C. Then after we can say there is a formula. A plus B plus C is equal to B plus C plus A. First of all, let's the group of them. Then after you have to group the second one. A plus B in bracket plus C is equal to B plus C plus A. Let's check that here. It is correct. Yeah, incorrect. Basically, it is a very simple. Okay. Let's look at this. I can say to you A plus B plus C is equal to B plus C plus A. Is it right? You can learn of them. A plus B in bracket, then after plus C, second one B plus C plus A. That's very simple. We can say this is left hand side, this is right hand side. This is A plus B plus C, B plus C plus A. Very simple. Very talkative. That is about that. Huh? I can say to you A plus B plus C is equal to A plus C plus A. Then after. Okay, if I say to you the examples with them, so you have to prove the left hand side equal to right hand side. You have to prove. Suppose that A is equal to 2, B is equal to 3, and C is equal to suppose that 4. Okay, we can say here A is equal to 2, B is equal to 3, and C is equal to 4. Then after what will? As for it, I can say to you the left hand side is equal to what? A plus B. A means 2, B means 3, C is 4. We can say 2 plus 3 plus 4 is equal to 3 to 5. 5 plus 4 equals then 9. This is your left hand side. Right hand side is equal to what? We can see B plus C means, yes, 3 plus 4. You can say plus, we can say 2. So 3 plus 4, we can say 7 plus 2 equals then 9. It is proof that left hand side is equal to right hand side. That's it. Okay, I hope you are understanding. Very simple, very common. Let's think about that. That's like this is a game. Okay, next things about that we have to okay. Second is associative law of addition. After there is existence of additive identity. 4. Existence of additive identity. Existence of additive identity. Suppose that for any integer, okay, for any integer means we can say A equals then suppose that 1, 2, 3, minus 1, minus 2, you can say minus 3. For anyone, suppose that. For any integer for we can say here. Okay. So if you add, A plus 0, if any integer, it should be always A. This is mean existence of additive identity for A is equal to any integer. Okay, when you will be just like if you add the 0 with them, so they will always to come as an integer. Basically, 0 is called additive identity for these integers. How is it possible? When a, suppose that there is a 1 plus 0 is equal to 1. Suppose that a is equal to minus 1, so we can say minus 1 plus 0 is equal to minus 1. So as this purpose for I will say to you, 0 is called additive identity of for inverse. This is called additive identity for inverse because a plus 0 is equal to a, 1 plus 0 is equal to 1, and a minus 1 plus 0 is equal to minus 1. At this condition for I can say to you, this is 0 is called what? 0 is called additive identity for inverse. 0 is called what? 0 is called additive. 0 is called what? 0 is called additive identity for inverse. Okay, 0 is called additive identity for inverse. Okay, I show to you some examples with this pattern. Same your integers will come. Then after existence of additive inverse. Existence of additive inverse. Existence of additive inverse. As for this, what we have to do? As for which we have to do here, just like a plus. What is additive inverse of a? We can say minus a. So plus minus is equal to a plus minus is minus a equal to a minus equal to 0. Same as well of this pattern, for this example here, 5 plus minus 5 is equal to what? Okay, so 5 is there a number, minus 5 is additive inverse of 5. Minus 5 is additive inverse of 5. So that we can say here 5 minus 5 equal to 0. So what is the conclusion of here? So additive inverse of minus 5 is 5. Yeah, we can say additive inverse of 5 is minus 5. Both are conditions apply at here. Okay, so wow, boom, the complete this here. So I think that about same things about for the subtraction. Okay, something will be changed into the multiplication and division also will change. So how was your class, dear students? Let's tell me in the comment box so that I will be prepared next video for you. Okay, till now, for have a nice day. Enjoy yourself, revise and prepare. Thank you. Have a nice day.